Question number 7. A system of moment of inertia I rotate from rest about a given axis. The angular acceleration alpha of the system is constant. What is the change in angular momentum when the system has made 4 complete rotations about the given axis? Now let's look at this question critically and note some key pointers we can pick from the question to aid us in our solution. The first one we can note from the question is that the system of moment of inertia rotate from rest. So the first thing we know that the system of moment of inertia rotate from rest. So it rotates from rest. This is the first key point. The second key point is that the angular acceleration alpha of the system is constant. The third one is that we are asked to find the change in angular momentum when the system has made 4 complete rotations about the given axis. Now, you should also know which particular topic this question is under. And this question is under rigid body mechanics. So let's use these key pointers we've picked to come up with a very good solution. Now, the first thing you're expected to know is to be able to define what angular momentum is. And it's defined as a product of an object moment of inertia and its angular velocity. So mathematically, the expression has been written there. Angular momentum is given as moment of inertia times angular velocity. And mind you, this is a vector quantity. Now, since the system rotates from rest, we can write an expression for the angular momentum of the system as the change in angular momentum is given as the final angular momentum of the system minus the initial angular momentum of the system. We are told that the initial angular velocity of the system is 0. Or it starts from rest, the body starts from rest. So it means that the initial angular velocity of the body is 0. So our change in angular momentum is equal to our final angular momentum of the system. Now also, the system undergoes 4 complete rotations. Now we have to change those rotations we are given into radians. So the angular displacement theta is given as 2 pi, which is standing for 1 complete rotation times 4, which is the number of times the rotation took place. So that is giving us an answer of 8 pi rad. Now you realize that in the question we are given, the time component is missing. So the rotational kinematics equation we can use is one that does not involve time. So the final angular velocity squared is equal to the initial angular velocity squared plus 2 times the angular acceleration times the angular displacement. Since we know that the system is starting from rest, the initial angular velocity is 0. So our formula becomes our final angular velocity squared is equal to 2 times alpha, which is our angular acceleration, times our angular displacement. And that should give us our final angular velocity to be 4 square root of angular acceleration times pi. Now we picking this equation and fixing it into a change in momentum of the system formula should give us our change in angular momentum of the system to be our moment of inertia, which is I, times the answer we got for our final angular velocity. And that should give us our change in momentum to be equal to 4 times our moment of inertia times the square root of pi times our angular acceleration. So this is our final answer. Now let's switch back to the question and choose from the possible answers, which is our answer. Now looking at all the answers we are given here, straight away we note that B is our correct answer.